Hey guys, welcome back. This is the last week of review, and this is my last best guess of what might be on the test. So let's do it. List the angles in ABC from smallest to largest. Okay, so we order the sides, least to greatest, right? These are all different lengths. Small, medium, and large. So 9, 11, and 14. And these are sides, and I can order the angles least to greatest using this information. So since 9 is the smallest, that means this is the smallest angle. Since 11 is the medium one, this has to be my medium angle. Since 14 is the longest, largest, that means A has to be the biggest. So order the angles from smallest to largest. B, C, and A. That is the order smallest to largest. Nice work, guys. All right, question number 2. It says, select all the correct statements regarding the figure. Okay, so we see that these are parallel, right? So that means this angle and this angle are corresponding. So those are equal. We also noticed these angles would be corresponding. So those are equal. Okay, what else? We got some right angles here. And I can see something we could figure out. If you can focus in on this triangle, right? This triangle has an angle that's 90, 25, and don't know. So we could solve for that angle up there. Okay, let's do that. So that would be x plus the 25 plus 90, all add up to 180. Or you could just kind of subtract these. $65. Okay, so this is 65. I'm not sure. Let's play around with this. MO is less than NO is less than MN. Let's look at this. MO is smallest, then NO, then this one. So if I believe that these are parallel, then I can say this is 65 and that is 65. I'm not positive I can, but I'm going to go with that, right? If that's true, then I can figure out what these two other angles are there. 180 minus the 61, right? Minus another 65 is 54. Okay, now I can say that, this side opposite the smallest, MO, okay. 61, NO, yep. And then 65 is the biggest, so MN is the biggest. So that's just kind of like the last problem. Can I say MNO is 54? MNO is 54. MNO is 54. Yep, I did come to that conclusion. Can I say MP plus OP is MN? Can I say MP plus OP equals MN? Those add up? No, that's weird. That doesn't look like something I could do. What about PMN equaling 86? PMN equaling 86. When I add together 61 and 65, I get 125. So I don't like that one. Now, could I conclude that MO plus NO is greater than MN? So let's look at that. Is MO, this length, plus NO, this length, greater than that length? Absolutely. That's our third side. So side 1 plus side 2 has to be greater than the third side, right? That's kind of our splat or triangle inequality theorem. All right. Question number 3. A triangle has 2 sides. What's the greatest whole number for the possible third? Okay, so we can set up this formula. Hopefully you remember it. We can add the 2 sides and subtract the 2 sides. And I like to take the bigger side minus the first side, right? So if I add these 2, and then I subtract these 2, oh wait, I messed this up. And again, that's why we're studying, right? I got it, the third side has to be, all right, add the 2, all right, subtract the 2, that looks a little bit better. So what do I get here? So 0.7, that would be 22.7. What do I get here? So that would be 0.3. I said 3. Okay. So what is the greatest whole number, possible length for the third side? So it looks like I can get up to 22, and I can't get any bigger than that. Does that kind of make sense? So what would that look like? Well, if this was 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or just a little less than that, 9.7, and this was 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then the largest side we could allow that third side before it goes splat is 22. 1, 2, 3, 4, 5, right? Is that kind of making sense? And so that's the point at which this is almost just collapsing and turning into a number line. Any bigger than that, like if we made it 23, it's too big. Okay, question number 4. Consider ABC in item 1. So thinking about this triangle over there, just in general, which of the following is a possible set of measures for its interior angles? Okay, so we know they have to go in this order, B, C, A. We also know they have to add up to 180. So let's check that first. This add up to 180? No. Does this add up? Excuse me. Does this add up to 180? 12, 13, 14, 15, 16, 17, 18. Okay, that was good. What about this? That one's good. Let's check this one. No, that one's not gonna work. Okay. So we've narrowed it down here. Now let's just make sure that the order is correct. So we can look at the middle to figure out which angle they're talking about. So angle B needs to be the smallest. Okay, we're good there. B is not the smallest. Oh, well, we've found our answer, haven't we? Now let's just double check it. Is C the next biggest? Yeah, 60. Is A the largest? Yes, 68. Cool, I like that question. Now looking at an inequality that relates to AB and FC. So AB, right, and FC. What do we know? Well, this is our hinge. So here's our alligator, right? Here's our alligator mouth, the top of his mouth and the bottom of his mouth. And I have to find the other alligator. It has the same length of jaws. So this is the top of the mouth and this is the bottom of the mouth. So that's where my hinge is. So now if I compare these angles, I sit here and I say, well, okay, the angle 29 is smaller, so this length has to be shorter. This stick in this alligator's mouth has to be shorter than if this one is a little bit larger. 48 is larger than 29, and so this stick could be longer. Now, how do we show that mathematically? Well, I can order my angles least to greatest. Angle D is smaller than angle, I guess it's C in this other picture. These are my angles, ordered least to greatest. And so their opposite sides would also be able to be ordered in the same way, least to greatest. So FC has to be shorter or less than a side AB, my sides. What is the inequality? Right there. Now, is there always like a little like something extra? And my answer is yes. I can't leave out the fact that if this angle was 29, this stick couldn't be absolutely 0. So I can't let it go to absolute 0, or it wouldn't make sense that this alligator mouth is open 29 degrees. All right, number 6, list the angles in the triangle from largest to smallest. Okay, no problem. I just need to be able to find these lengths. So it's kind of hard, isn't it? They all look kind of similar. So I have to picture these right triangles and then find their hypotenuses. I technically am gonna have to find the lengths of each of these hypotenuses. So this hypotenuse is made out of a 4 and a 4. So 4 squared and take the square root. That's the length of the hypotenuse of the yellow triangle. Our orange triangle is a 2 by 1, 2, 3, 4, 5. So 2 squared plus 5 squared and take the square root is the length of the hypotenuse of the orange triangle. And this triangle is 1, 2, 3, 4, 5, 6, 1. So it will be the length 1 squared plus 6 squared and take the square root. So using my calculator, I might not even need it. I get 16 plus 16 or the square root of 32. So that'll give me a decimal. What about this one? 1 squared plus 36. That's the square root of 37. So this one is, right, a little bit bigger when I compare. And this last one, 2 squared is 4, 5 squared is 25. So that's the square root of 29. So each of these are decimals. Can I order them least to greatest? Absolutely. This is the square root of 29, square root of 32, square root of 37. So I can order these least to greatest. That. And those are my sides. And so that should correspond with the angle. So opposite the shortest side is this angle M. Opposite the square root of 32 is angle K. Opposite the square root of 37 is angle L. I've listed the angles, which is what they asked me to do. List the angles least to greatest. Cool. Way cool. I like that one. Okay. Oh, awesome. Bummer. Okay. Only a handful or more. Let's do it. Which of the following represents a possible side length of a triangle? Okay, so we want to take the two smaller sides and figure out if that matches. So I'm going to use this room under number 8. So you subtract the two sides and you add the two sides to figure out if this is a possible third side, if it's an acceptable third side. So it's 15, 16. No, so it's too big. I'm going to do it again. Take the two smaller sides, subtract the two sides, add the two sides. Ooh, no, too big. 12 does not fit between 1.1 and 10.5. So let's do it again. Subtract the two smaller sides and add the two sides. It would be 15.5. Whoops, I forgot to subtract the two sides. Ooh, but it's just not working. 16.1 is too big. So I'm thinking this works. Let's try it out. Our two smaller sides. Subtract the two sides. Add the two sides. So is 14.6 between there? Yes, it's just barely between there, and we're going to accept that as our answer. Cool. That's a popular question. I would not be surprised if 7 was on your test. It's very popular. Okay, number 8. Mandy designing a triangular flower bud. If the length of 2 of the sides are 3 feet and 5 feet, what are the possible lengths of the third? Okay, so I'm just going to do this the same way, right? If 2 of the sides are 3 and 5, then to set this up, to find the length of the third side, I can subtract the 2 sides and add the 2 sides. Same type of question. So the third side has to stay between 2 and 8. It can't be 2 though, and it can't be 8. So what are some possible lengths? Well, if they want some exact lengths in feet, like maybe you're buying boards and you don't want fractions of a board, then 3, 4, 5, 6, or 7 would be fine. Those are some possible lengths. 8 is too big and 2 is too small. That's an inequality and not unequal to inequality. All right, looking at 10, that's another alligator mouth question, right? It looks like this alligator, here's the top of the jaw, and there's the bottom of the jaw. So this is the angle we're going to investigate. Here is my hinge. Here's my top of the jaw, and here's my bottom of the jaw, and here's the angle I'm going to investigate. And it's a different angle, right? So since this one's smaller, that will make this stick shorter. Since this angle is bigger, it's open wider, this will make this stick longer. Right? So how do I set this up? I usually order the angles least to greatest. So the 75-degree angle is smaller than the 105. I've ordered my angles least to greatest. And so the shorter side, 12, is less than 18. I ordered my sides. So, but that didn't really help me. Was there another alligator lurking there? So let me get my highlighter. I've got this alligator. Notice I missed this alligator. Oh, so that's a 90. Interesting. So I could actually have ordered more angles. 75, 90, and 105. So this one's shorter, this one's longer, and this one's something in the middle of the two. So 12, 2x minus 3, and 18. Okay, now let's do some algebra. All right, so I can add 3 to all, the left and the right. So I get this. All right, and then I can divide 2 from each one, and I get this. I could turn this into a decimal or just leave my answer just like that. That is an inequality explaining the possible values of x. All right. Now, the last two. It says, question number 9, consider the figure. So here's our alligator, top of the jaw, bottom of the jaw, so we can investigate this angle. And here's my top of the jaw, or top of the jaw, and bottom of the jaw. So this is my angle, or my hinge I'm going to investigate, and those are different. And so let's see, since this stick is shorter, that will force this angle to be smaller. Since this stick is longer, that'll force this angle to be bigger. So if we order these sides, least to greatest, 12 and 14, I've ordered the sides. I can order the angle. So the angle that goes with the 12 is 4x minus 12. And the angle that goes with the 14 stick is 56, the angles. Can I solve for x? Sure. Add 12 to each side. But wait a minute, let's think about this for a minute. Rewind. Can I let E be so small that it's not open at all? Well, no, because then a 12 stick wouldn't fit inside. So I have to make sure the side doesn't go all the way to 0, right? So I gotta make sure the angle doesn't go to 0 either. Okay, so I'm gonna add 12 to all sides. Okay, and then I'm gonna divide 4 from each one. Divide 4 from each one. So 12 divided by 4 is 3. 4 divided by 4 is 1. So I just have the x left. 68 divided by 4. I get 17. Nice. That's not what I wanted to do. I wanted to highlight that. Okay. 11, last one. Can't wait. Ooh, got a lot of alligator mouths here. There's a lot going on here. Okay, so if I had an alligator, it looks like my alligator is a 5 and a 5. You see this length right here. All right, I got another alligator, 5 and a 5, right? So this is its mouth. It's pointing at a 4. So that's the same stick. So that means these two angles have to be the same size. Okay, whatever they are, they're the same size. And that should make sense because this triangle looks to be congruent to that triangle because of side similarity. So if all their sides are equal, all their angles are going to have to be equal too. Right? So maybe I want, let's see if we get to that. Maybe one of these questions has that. So this would be angle B. Would angle ABD be equal to BDC? Yeah, that's this one that we've highlighted right there. So this one would be true. Those are because of congruent angles. Would BAD be congruent with this triangle, this angle, BAD, be congruent to EAD? No, that's a totally different type of triangle over there. That's not in my other triangle. Okay, now let's just solve for our inequalities. So where else can I kind of look at an alligator mouth? Well, I could compare this alligator mouth, a 4 on the top of the mouth and a 5 on the bottom, right? A 4 on the top of the mouth and a 5 on the bottom. You see there? See, I can compare these angles with this length and this angle, which is different to this length. See, it's a longer stick than fits in that mouth. So I know for sure that this angle at C, ooh, they don't have me looking at the angle at C. All right, they have me looking at the angle at A. Okay, so that's fine. This is a 4, bottom of mouth. This is a 5. It's fine. Let's look at this one. This one is a 5, top of the mouth. And this would be my angle to compare to. Yeah, that stick is longer. So I know this angle at D. This angle at D has to be bigger than the angle at E. Absolutely. And has to be bigger than the angle at A. Yes, absolutely. What about, would the angle at A be greater than the angle at B? So EAB. Then I'm just looking at this one, right? This is a 3, 4, 5. This angle, small, right? EAD. Or excuse me, EAB. This angle, EAB, has to be bigger than ABC. That's an interesting question. Let me look at that for a minute. Well, these are isosceles, so those angles equal. These are isosceles, so those angles are equal. This angle's different. This is opposite a 3, so this one would be the smallest angle. I don't necessarily know. So this one I'm not sure of. Let's look at this last one. DBC DBC is greater than EAD. And that would be, that's got a 5 stick in it, doesn't it? And this only has a 3 stick in it. So that would be true. This angle at B has to be bigger than this angle back at A. We know that this angle is smaller. Okay, nice work, guys. See you at the